In this video, I'm going to walk through some data analysis in ENVI with the 15 band data from the MicaSense triple cam. ENVI is it's a super powerful tool for multispectral and hyperspectral data analysis. You can do a ton of stuff with it. I'm only gonna, in this video, I'm gonna just sort of scratch the surface on spectral analysis, particularly getting the bands entered correctly, and then going through a machine learning classification example. But I think it'll be pretty useful for anybody with the triple or the dual cam or the Altum or the RedEdge-P or even the Centera 6X for that matter. Really, if you're doing any kind of multispectral analysis, it'll be good content. So with that, and you know what, while I was doing that introduction, I just thought of something. I probably need to make sure that um, I guess I don't need, so ENVI has a machine learning module, and it just occurred to me that I don't have that, but that's okay because the classification tools that are not um, machine learning are still pretty good. And in some instances, I've seen them perform better than the machine learning classification. So I think what we'll end up doing is we'll use this supervised classification. So the first thing I'm going to do is I'm going to open up the data set that we processed in Metashape. So this was in the previous video, I walked through how to process a 15 band data set in Metashape. Um, I'm I think when I processed this one, I had the Pancro band in there as well, and if you watch that video, you'll see that there were some gaps in the point cloud in the middle here, and I think that might be one of the reasons, or the reason that we had this issue right here where it was putting crops where they don't exist. But before I did that, I ran another Metashape processing just with the 15 spectral bands and without the Pancro, and I didn't have that, and the data came out a lot cleaner. So I think I'm going to use that for the ENVI example. And we really only need the spectral data anyways for classification. So we'll pull that up. Okay, so and I've got ENVI running on my Mac, and that's why it looks a little weird, like a little Windows 95-esque. Um, but let me find the one that I had. Triple ortho, multispectral only. This is the one. Okay, so as you can see, there's no weirdness going on that road in the middle like there was with the Pancro-band data set. Again, not sure why that was happening, but it's not there. So the first thing I want to point out is this is a really cool tool down here in ENVI. It lets you slide around the blue, green, and red spectral, the blue, green, and red bands to different. You can assign different bands to the blue, green, and red. So you're basically making like custom composites very quickly, just like by moving it around. So it'll reproject. It takes a few seconds to do that, but it'll reproject the green. Yeah, so you can basically like quickly make um, different spectral bands. And let me just pan around here and look at this. It's a little touchy. If you lose it, you can just hit this button and then it'll bring it back to center. But what's kind of the first thing we got to do is we got to assign the the bandwidth or the center wavelength to the bands, because ENVI doesn't know what's what. Even though you see that they're named, that's just the name of the band. It's not like it's not in the metadata what spectral band each band is. So to do that, we go over to this layer on the left, or this menu on the left. We go down to view metadata, and then go to spectral, and you can see that wavelengths, there's nothing there. Um, So to add the wavelengths, we'll hit edit metadata and then go to spectral, and then we hit this little green add button and we find wavelength. Give this a second to settle down. Okay, so fortunately, Metashape named them, so I don't have to figure out what's what too much. So I'm just going to put 444 for the blue, and this one is going to be 475 because that's the other blue band. This one is 502. This one's 531. $550, and this is probably another standard band. What would that be? That'd be 475, 560, I think. And this is 668. So it looks like the standard RedEdge-P on the triple setup, it's not bringing over the anything on the wavelengths. So I just remember that it's 475, 560, 668, 717, and 840. 678. $705. Almost done. Near infrared. 840. So now ENVI should, yeah, ENVI generated a true RGB composite because now it knows what the bands represent. And so this is helpful because now they have some preset composites. So if you open this up, not showing it because I'm only recording part of my screen. Let me just adjust this real quick. If you're running on a Windows, this is going to be a lot smoother. But you can see now it's got true color, color infrared, shortwave infrared, false color. So if I do CIR, it'll find the bands for CIR and automatically generate that. See what shortwave infrared looks like. Let's go back to true color. Okay, I'm gonna make this a little bigger now that you know what's under that menu. But when I'm doing a classification, when I'm trying to create ROIs for a classification, I typically will just hit this random button. So it says select random band combination. So I'll click that until I come up with a composite that does something that makes things pop out. There's something interesting right there. Wonder what that is. Looks like there's some other ones too. Maybe it's like a weed or something. So this could be like a good starting point potentially. And you can see there's a few other ones in here too. I don't know what those are. But what we can do in ENVI is it lets us create ROIs for interesting things that are happening within the data set. And then we can run a classifier to find other similar spectral profiles throughout the data set. And something else I should show you is um, if I right click on the layer and then I go to profiles and I go to spectral, um, you can click around and it'll show you the spectral profile of different things in the image. So you just click to different objects and then you can see that the spectral profile is changing automatically. And something I'm not going to get into here is ENVI has just like tons of spectral libraries and spectral classification tools. Um, like you can select. I think if I hit import spectral library, so they've got all these libraries that you can use to try to automatically identify stuff. A lot of times this is associated with hyperspectral data analysis, looking for different mineral types and that sort of thing. I've never used it for like vegetation, but I think there are vegetation like libraries. Like never looked at this one before, but if I click on this vegetation Beckman 3132, it shows that it's got a bunch of different classifiers or a bunch of different classes for different vegetation types. I don't think any of these are going to show up in this data set, but what it would do if we try to run this is it would look for spectral profiles that are close matches with these different types of plant species. So lots of cool stuff in ENVI that I'm not going to get into. But what I do want to show you in this video is just creating ROIs of things that I think might be different and then running a classifier on them. So it's super easy. If I go up to region of interest, I can create an ROI, and there are a few different ways you can do it. You can use points, where you just click pixels. Actually, just kidding. Let me delete that. And I go to pixel. And then you can like basically specify the brush size. But if I zoom in, I can click different pixels and it'll basically select that as my ROI. Um, Another thing you can do a lot of times when people are doing, let me just X out of here. When people are looking at data, a lot of times they like to change the interpolation to, um, let's see, nearest neighbor maybe? Try that. Yeah. So this is going to show us the actual pixels in the data set and not some like blurry thing going on. But if I double click on the ROI, I can keep working on that. So I'm just gonna, let's see, delete. I'm gonna go back to pixels and I'm gonna keep adding to this ROI one. And I'll name this, I don't know, it doesn't matter. Purple blobs in the field. And now let's look for some more. I think there were some up in this area. That should be good. Um, and now let's make another class that we'll just call field crop 1. And for this one, I'll just use polygon. So I'll just grab a bunch of polygons, complete and accept. And if you right click, it lets you complete and accept the polygon. I'll change this color so it stands out a little more. There we go. Actually, maybe what I'll do, it looks like there's some like different variation in the field. I don't know why some of this is green and some of this is like a little darker green, but let's create 2 classes for that just because it's interesting. And let me just X out of here and open this back up. That was grabbing. I'll just get rid of all these just to make sure I'm not. Okay, so field crop 1, let's just grab this whole area. And that's probably good enough. And you probably, if this wasn't a demonstration video, I'd probably spend more time building ROIs, but just for the sake of demonstration, I think I'll just make a few for each one. Let's call the next one light green field crop 1. And I think we can stick with polygon creation for this. And I see some more purple blobs, so maybe we'll grab some of those. And let's change the purple blobs to purple, just so we don't confuse ourselves. And I'll make a couple more classes before we run the classifier. We'll make one for the road. And we'll color that like a brown. And then maybe we'll make one that's just called dirt. The dirt and road might get confused because they probably have similar spectral profiles. We'll make this black. All right, and then now it does have something weird going on in there. If you see that, there's like this weird blob over here. Looks like it carried over from the other side, and there's like a weird road element going on. All right, now let's call this field crop 2. And we'll make one more. And we'll color that, I don't know, blue. Okay. So we could, I mean, you could make tons of different classifications or tons of different training data types. Like I could probably go over here and make another one for this, whatever that is. There's some alignment issues going on over there. I don't know what that is. But we'll stop with that. Okay, so now under the classification folder, we can go to supervised classification, and there's a bunch of different ways that we can do this. I typically just do spectral angle mapper. So the input raster is the 15-band data set. The input ROIs are what we just created. So they're right here. We'll select, they're all selected already. And then we'll click display result. And you can either save it to your computer, or if you just want to save it locally, I think that's what it's called, you can just put an exclamation point in, and it says a temporary file will be generated. So if you're just messing around and you don't want to save a bunch of different layers to your computer, you just throw in the exclamation point and it'll run it. I think, well, it's hard for me to, in this like Mac format, it's hard for me to tell if display result is selected or not. I think it is, but we'll give it a try. Okay, so classification is done. And yeah, that's pretty much it. So you can run a classifier like that pretty quickly. You can see that it could be better if we spent more time on training data, but those purple blobs were kind of interesting. So if we uncheck everything else and just look for the purple blobs, it looks like there's some noise over on this side, but did it classify all the purple blobs? It pretty much did. So if you were like, if for some reason you knew that those purple blobs were were like a weed in your field, this would be a good way to understand like what the extent of those weeds in your field were. Um, let's change the color so that it pops out a little bit more, make it yellow. There. And let's shut off these guys. Okay, so on this side of the field, that's pretty cool. It shows basically where all those purple, um, at least in this composite, like where all the purple anomalies are occurring. It looks like the spectral profile for those purple things is very similar on this side. So maybe it's just dirt. Maybe it's just like dead crop or something. I don't know. But you can hopefully this just like gives you an idea of like the flexibility and ability and like quick ability to create classes and run classifications of spectral data. Um, but that's pretty much all I wanted to cover. And if you have any other questions or you find this interesting, um, love it if you'd like the video, subscribe to the channel, and feel free to reach out to Multispectral Systems by going to multispectralsystems.com, and I'd be happy to answer any other questions for you. Thanks.